So this water chemistry test is going to be dissolved oxygen. And as you would guess, the more oxygen in the water, the better it's going to be for life. All of life needs oxygen, whether it's plants or humans or bacteria or animals, other animals. We need oxygen to breathe so we can get energy through cellular respiration. So dissolved oxygen is a little strange because we have to measure the percent saturation of the dissolved oxygen in the water. And again, what these animals are doing is breathing the oxygen through the water. They've generally got gills or some other way of ingesting the water. So that's where they're getting the oxygen from. It's not from the air. And the more oxygen you would guess in the water, the better they can survive. So as I was saying, the percent saturation of oxygen of the water actually changes depending on the temperature of the water. So colder water can hold more oxygen than or warmer water can. So in all these tests, or in the dissolved oxygen test, we have to figure out what the temperature is first. And that way we can scale from there. So I have my water sample here in a graduated cylinder, and I'm going to take the thermometer just like we did with the water when we were out sampling the pond, and I'm going to stick it into our water sample to first get a baseline temperature reading. So much suspense involved here. Okay, so the temperature reading I'm getting right now, we've been inside for a while, is 25 degrees Celsius. So again, that's about room temperature. So that's what we're going to use for our dissolved oxygen reading, and we'll write that behind the dissolved oxygen output whenever you go to do the measurements. So now we're ready to do the actual test. So as our other test, we have a little test tube. We're going to fill it up, actually this time to the very top. But we have to be careful because we don't want to introduce oxygen into the tube when we do this. So we can't just pour the water in and get air bubbles that will disrupt our measurement. So what I've done here, and again, this is our pond water. I put it in a graduated cylinder. I'm going to very carefully pour this pond water in. So it's at the very top of the graduated cylinder. So when I go to fill up my tube, I'm going to submerge it this way, and that way the water will come in without me pouring it in. So I'm going to put in my tube. And it's filling up now with water. No bubbles are getting in, which is good. Now I'm going to pull it out very carefully. And so the water is almost at the very top. I want to make sure the water is flush with the top of the tube that I'm using. So I'm just going to use this pipette to drop a couple more drops of water in here. So now it's at the very top. So what I'm going to do next is add 2 tablets, which, like the other tests, should change color. And the greater the color change, the more the dissolved oxygen. And again, that's a good thing. We want more dissolved oxygen in our sample. So I'm going to put 2 tablets in here. That one fell apart before it made it in. Okay, that one just exploded. So I'm going to do another one here. There we go. And then I'm going to cap this tube. Now water is going to come out the top because we want it to be as filled as possible and not introduce air into there. I'm going to very carefully cap this tube without introducing air bubbles. And now we're ready to go. And then what I'm going to do is invert this. It takes a little longer for this test, so 3 to 4 minutes of inversion. That will mix the tube with the water. And then we'll see if there's a color change and compare it to a chart just like we've done with the other tests. So that is the dissolved oxygen test.